So to find the height that limestone is on right now, we know that she vertically jumped from the ground to the tree, and so that means there's no x component to the question. When we set up our axes, we made it so that the upward direction is the positive direction, meaning that acceleration due to gravity is negative because it's downward, so it's negative 9.8 meters per second squared. We know that the final velocity is 0 meters per second because she lands on the branch at her maximum height, and at the highest point, velocity is 0, but acceleration is not, hence there's a value. We know that the time measured is 1.05 seconds from where she starts to where she ends. We don't know initial velocity, and we do not know the vertical displacement. Now, we can use kinematic equations to find vertical displacement. Unfortunately, for this question, you need initial velocity. So to find initial velocity, we can use this equation, which we can't solve for. So we solve for initial velocity by subbing in the values, and we get 10.28 meters per second, which due to sig figs is actually 10 meters per second. Sub that into this equation now, and we get vertical displacement of 5.102 meters, which due to sig figs is actually 5.1 meters.
Now, in order to calculate for Einstein's initial velocity, we will be using this equation here. We've defined our positive axes to be in upwards direction. Therefore, the acceleration acting on Einstein in this instance, the acceleration due to gravity, is negative 9.8 meters per second squared. Now, Einstein plans to reach his maximum height at where the location of limestone is on the tree. Therefore, his final velocity would be 0 meters per second. And we are solving for delta y because there is no horizontal component in this case. Now, delta y is not the same as the previous question, that is 5.1 meters. Actually, because Einstein is elevated, or he is starting off at the top of physics girl's head, that physics girl or physics girl height would be his starting off point. Therefore, in order to calculate for delta y in this instance, we would have to subtract 5.1 meters, that is the height of the tree, from the height of physics girl. And because of that, we would get a delta y of 4.1 meters. Now, in order to solve for Einstein's initial velocity, we would simply plug in the values, that is acceleration, delta y, and the final velocity, and solve for the initial velocity. Once we do so, the initial velocity is found to be 8.96 meters per second, and when rounded due to sig figs, Einstein's initial velocity would be 9.0 meters per second.